Okay, let's see if I can make things a little bit clear here as to what's going on. I'm back down in my workshop. I want to show you the actual, how close the ball gets on the entry point. Right. When I first started, this was about 2 inches. It went to 1 inch, and now I have it the width of the ball, about a ½ inch. Another ½ inch and it will enter the SMOT. I've gotten a number of emails saying no, it won't enter the SMOT because the ball loses so much energy to get to the entry level. If you'll notice that the ball actually picks up speed at that point. It's not losing energy, it's gaining energy. Alright? It's only necessary to raise this another ½ inch to achieve another ½ inch in lift, and it will enter the SMOT. A lot of people have told me that no, there's a gate at the SMOT entry level. There is no entry level gate. The gate is at the exit, and as you can see, it exits just fine, goes all the way around. It's very, very close to entering. Now, I have built a little down and dirty second SMOT. I'm down here in my shop. I'm going to show you how this process works. We're going to take I moved it over from the other SMOT. Now, again, what people are saying is that there's no way it will enter the other SMOT. It doesn't have enough energy. It's using all its energy getting over there. They're simply not seeing it. So I think this will make it probably pretty clear. I'm going to set the ball on a rail. Aha. When it enters the U-channel right here, there's a little bit of inertia, and actually it's going quite fast through this. As you could see, this is a glass plate. It was the same glass plate that I had over here. I just moved it over here. As you can see, the ball actually speeds up going through the connecting U-channel over the glass plate, falls onto the SMOT U-channel. This is the U-channel is level with the glass plate. There's a little bit of inertia, and the SMOT will pick it up about right here. It actually sucks it into it, and then it falls over. I have a way of which I can get this distance that it falls over to be compensated. That's what happens in here. This is a scoop. Let me show you a little better picture of the scoop that I was experimenting with. Okay? That might show it a little better. This is what kind of makes this whole thing work. All right? When the ball falls off the U-channel, it comes here, and then it'll go back up again. It lands much, much higher. Without this is what makes this whole thing work. Without this scoop device, which I have incorporated right here, it's just a little darker, you can't see it, it would not work. But it does work because of the scoop device. So let me show this one more time so we can get people to understand what's going on here. The ball goes down, the U-channel speeds up. There you go. I mean, it can't be more obvious than that. It's not slowing down when it hits the U-channel, the entry point. It's actually speeding up. It's not losing energy. It speeds up. It's gaining energy. And when it hits the U-channel SMOT, it's sucked into the SMOT. It falls over. At this point, it's dropping into the scoop, and it continues on around. It's very obvious. It's just as obvious as can be at this point. That's why I put this together last night about 2 in the morning just to show. So again, and I'm going to move the glass plate from this over to here, over to the other SMOT, and we'll now do it from this angle. There it is, guys. You can see how close the ball is. It's very, very close. No one has ever gotten this close before. Impossible. Well, it's not impossible, obviously. I needed to get from here to there, about the width of the ball. I've gone from 2 inches to 1 inch to this. You know, I'll get that worked out. So when that happens, we go from this to this. I may be on overkill here, but I think you understand what's going on. Thank you much. Bye.